Hey guys, welcome back to chapter 3. What we're going to do now is spend some time getting to know why we just spent an entire chapter talking about electrons. So electrons are the dictators for periodic trends. So we're going to look at some trends in the periodic table, and we're going to talk about how electrons are the ones that dictate those trends. So why are there properties in the periodic table? So the periodic table is named periodic because every so often we see this repeating trend. So much like an octet in music repeats every 8 notes, we see that the periodic table every so often will repeat itself as well. What determines or causes these properties? Well, it has to do with electrons. So we're going to look at a series of periodic tables, and we're going to just kind of get to know the periodic table a little bit better. And then the next few videos will be some very particular trends that I want you guys to learn. So the first one is valence electrons. So up until this point, we have identified valence electrons based on the electron configuration. So finding the electrons in the highest energy level. So that is true. We can always figure out valence electrons that way. But what we find is that these atoms are stacked very distinctively into groups that could help us determine valence electrons a little bit faster. So what we see here is the periodic table. What I've done is I've kind of taken that D block out of the middle, so that would go right here, and then I shoved the two sides of the periodic table together. So we've got column 1, 2, and then here's where that D block would be. Jump over that, and this is 3 or 13, 14, 15, 16, 17, 18. Okay. For S block and P block elements, we can determine valence electrons by looking at the number at the top of the column. So for all of the elements that are in this first column, they're going to have 1 valence electron. All of the elements in this second column are going to have 2 valence electrons. 3, 4, 5, 6, 7, and all of the elements in that very last column on the periodic table are going to have 8 valence electrons. So how does this connect to electron configurations? Well, as we are moving across the periodic table, when we're in this first column, that's where we put that first electron into the new energy level. So for example, sodium here, right? So we fill up the P block, we end this row, we come down, we put our first electron into the third energy level. So there's 1 electron in that new energy level, 1 valence. Then we put 2 into the third energy level, and then 3, 4, 5, 6, 7, 8. Okay. So when we get to this last column, that energy level is full, and then we would have to add a new one on. So we stack all of those in a column, and now all of these have 1 valence, all of these have 2, so on and so forth. So these elements being stacked very strategically was not an accident. That was something that was very well researched. So what we're going to do now is just quickly see kind of how the periodic table took shape. And then we're going to look at some regions on the periodic table that are going to be very helpful to know. You'll need to know these regions. So when scientists started to discover elements, we had just a collection of elements. Unfortunately, we didn't have any way to kind of organize our thoughts or organize those elements. But what scientists started to notice is that some of these elements had repeatable properties, repeatable patterns. What sorts of properties were they looking at? Does it conduct electricity? Does it not conduct electricity? What's the melting point? What's the freezing point? All kinds of, does it react with this? How does it react with that? So they looked at all kinds of different properties, all the things that they were observing. And what they found is that those properties would repeat about every 8 elements or so, much like an octet. Scientists started to stack the periodic table in all kinds of different fashions. So they started to take maybe all of the green ones here and put them in a line left to right. They try to take the green ones and put them in a line top to bottom. So there's all kinds of different ways that they try to organize their thoughts. They try to put them in order of weight. That didn't work. And then once we started to discover protons, they put them in order by their protons. That did work. So here's where we have kind of the beginnings, the start of the modern periodic table. So we take these elements that have repeating patterns, we stack them one on top of the other, and we get kind of the beginnings of our periodic table as we know it. So I'm going to show you kind of a series of periodic tables. They're going to be very strategically colored to talk about different topics. So here's the first look at our modern periodic table. So what this one highlights is going to be the groups, names of different groups. So the columns here, we call them groups. Sometimes they're called families. So families, just like your family, you have a lot of the same characteristics, the same properties. Same thing with the families on the periodic table. They have a lot of the same characteristics. So the first one that we see here is our noble gases. That's over here, 8A or 18. The noble gases are what I like to call the cool kids of the periodic table. They have the most stable electron configuration. With that energy level being full, that makes them particularly stable. All of chemistry is the rest of the elements trying to be like the noble gases, have a configuration like the noble gases. Right next to those, we see the halogens. So the halogens are very, very close to being like the noble gases. They're one step away. So halogens are very, very reactive. So they will react with almost anything and everything to get that one extra electron and be like the noble gases. So our halogens are very reactive elements. If we go one step the other way, so here's our noble gases, we go to the other side, we've got our alkali metals. So alkali metals also are one step away from being like the noble gases, and they also are very reactive. These guys just like to be a little bit more dramatic. So these guys will react, and they will react with a lot of drama. If you want to see that in action, Google sodium in water, and you'll see some really cool reactions. The ones next to those are alkaline earth metals. So alkaline earth metals are still very close to being like the noble gases, so 2 away. So they are also very reactive. Not as reactive as the alkali metals. So still very reactive, still fairly dramatic, but not nearly as dramatic as the alkali metals. So that's 4 groups that I do want you guys to know the names of. So alkali metals, alkaline earth metals, halogens, and noble gases. The next one, we're going to talk about main group versus transition. So we've alluded to this a little bit, but the main group elements are our S block and P block. So our main group elements are very predictive. They follow the rules. We can look at trends and trust that the trend is going to fit for all of these elements. Here we've got our transition elements or our transition metals. The transition elements are the D block. We know they march to the beat of their own drum. So they are always the exception to the rule. We'll set a trend and then they won't follow it. So the transition elements are just kind of something to keep an eye on as kind of exceptions to the rule. So a little red flag goes up. And then the last trend that I want you guys to know are the metals, non-metals, and transition metals, or no, excuse me, metalloids. So our metals are the tan color here. So the vast majority of the periodic table is metals. Metals are exactly what you would think of if you think of a metal. So they're solid at room temperature, shiny, malleable, we can mold them. They conduct electricity, they conduct heat. So most of our periodic table we would consider a metal. This teeny tiny little blue section over here in the periodic table in hydrogen, these are our non-metals. So non-metals are kind of the opposite of what you would expect from a metal. So they are typically a gas or liquid at room temperature, do not conduct electricity, do not conduct heat. While it's a teeny tiny little section of the periodic table, don't sleep on them. These guys have big, big, big chemistry. So looking at the atoms in this section, we've got an entire division of chemistry called organic chemistry that deals with those elements by themselves. So small little section in the periodic table, but very, very large chemistry to talk about. And then we've got this kind of stair step going down. These would be our metalloids. So metalloids are kind of the transition from metal to non-metal. So they conduct electricity, just not as well. They conduct heat, just not as efficiently. So they are just kind of that transition from the metal to the non-metal. Your ability to identify metal and non-metal quickly is going to be an important skill for you to have in the next unit, because that'll be the first thing we need to identify so we know what kind of bonds these atoms are going to make. So of these three periodic tables, you will need to identify metal and non-metal. You'll need to identify main group and transition, and then you'll need to know the four names of the groups that are listed on this slide. So that's it for the periodic table. I hope you guys found this helpful.